Hello everyone, welcome to TriRights, the new era of learning. My name is Sheikh Abdul Rafiq and I am your data science trainer. Let's move to the topic. Today's topic is data science regression table p-value. We all know about the p-value in regression table. So p-value is nothing but probability value, right? In regression table in data science provide key statistic to evaluate the relationship between one independent variable and dependent variable. Okay, one crucial matrix in this table is the p-value, okay, which helps to determine the significance of the each predictor value, or you can say each predictor variable. Okay, so p-value in regression is nothing but the p-value test whether a predictor value has a statistical significance impact on the dependent variable. So in other case, we call the threshold a p-value less than 0.05 typically indicates. So 0.05 is nothing but 5% that the variable is significant mean it is likely affected to the outcome. So in that we have low p-value and high p-value. So low p-value is nothing but 0. P-value is less than 0.05 and greater than 0.05. So p-value is a probability of 0 and 1. So okay, with this assumption that the null hypothesis is true. Okay. So p-value is also known as a probability value at the which null hypothesis are rejected. Okay, where null hypothesis can rejected in the value of true. Okay, in this we have if p-value are generally expressed as decimal. Okay, 0 and 1 is nothing but decimal. Usually p-value is 0.05 has it used has 0.05 is nothing but 5% of the overall table, overall graph. So in this low p-value, we can consider low p-value. Low p-value has less than 0.05, and here we have high p-value, nothing but greater than 0.05. Okay. So in the case of low p-value, again, wait. So in the case of low p-value, it indicates it means that the coefficient is likely not equal to zero. So it is the low p-value is nothing but it indicates is not equal to zero. Where the high p-value means uh, that we cannot conclude the explanatory variable effect to the dependent variable. So it did not consider, right? Okay. And in it, we also have a high p-value is also called as insignificant p-value. So we also call it insignificant as p-value. Okay. So we test if the true value of the coefficient is equal to zero. That means no relationship. The statistical test for the is called hypothesis testing. So moving to the topic, first we all know about the hypothesis testing. Hypothesis testing is nothing but so hypothesis testing is nothing but that is hypothesis is a statement assumption of claim about the value of the parameter we can consider as mean, variance, median, etc. Okay, a hypothesis is an educated gives about the something that in the real world, in the world around you. So in the case of we can take in hypothesis nothing but it given the testing value. So where the value can exist. Okay, so the assumption of we can climb as a mean, variance, mid. We all know. So it takes the assumption guess, right? It's take the particular guess to which we can consider. So in this hypothesis testing, we has a two samples. Okay, sample one has sample hypothesis. So in this we can consider sample hypothesis, and another has composite composite hypothesis. Okay, so in this the composite hypothesis. So simple hypothesis is nothing but when a hypothesis specifically and extract value of parameter. So nothing but in simple words, simple hypothesis, nothing but it assumes it 100% sure about the value, exact value. So at the time we declare as simple hypothesis, it also know the value and it declares that it is 100% exact value of the parameter. So at the time we consider as simple hypothesis. So in the composite hypothesis, so it actually sum between different. So if the hypothesis specially arrange the value, then it is called as composite hypothesis. It arrange the values. Okay, usually it arranges the values into the order. So in this we can consider hypothesis test has two statements, null hypothesis and the alternate hypothesis. Okay, the null hypothesis can be shortly written as HO. So we can take as HO0. We can consider as HO0. It is nothing but HO, like we take H0 or HO we take HO. We consider HO is nothing but equal to 0. P value, P value equal to 0. Like if we consider as, in simple terms, I can say, let's take previous statement. In previous statement, we assume a graph has an average pulse and intercept. No? So from that, I take average pulse. So average pulse equal to 0 is a HO, right? From HA, it's quite opposite. Okay, average pulse is not equal to 0. So it means I take indicator as like this, not equal to 0, not equal to 0. Okay, same case, it is continue in the intercept too. So okay, intercept also is considered same. In intercept also when it is equal to 0 and it has same as it's not equal to 0. Intercept not equal to 0, not equal to 0. So in the signal of not equal to means there is no equal relationship between the two both variables. Okay. So like that we can assume the value of the p value. So in the case, let us I give an example of little bit example I have to explain you. So for the more clear and idea. So let's move to the graph. Let's take a random example. Okay. Let's I taking a flip of coin heads and tails. So I have a straight line and in that I has these values we called as constant. So in this we have the value of critical value. So let's take as a critical value, has a critical value. So in that I take these two critical values and I has a rejected hypothesis. Okay. I'm drawing to perfect. Okay, right. Okay. A little bit I'm bending this. Okay. Okay, here we have a graph called like this. So in this graph, I consider as this is my rejected value, right? Okay, this is my critical base value. So this is my critical value. So this is my critical value. Same as this two also is my critical value. Okay, this both are as my critical value. So these both are my critical values. So let's take an example of coin flip. If we take a coin has probability chances of heads and tails when we flip the coin. So in that same case, I have an assumption of 50-50 chances. Let I take a 50-50 chances in a pre case. So I take a star, consist of this, I take a straight line. Okay. I take a red line to the straight. So from here, I consider a line. So from here. So in that area, I has this is my frequency, and in this I have coin flip. This is my head data. This is my head data. I get a head. So the chances is 50. So this is my purple. So I have a data like this. So it is my head's probability and this is my tail probability. This is my head. So I consider it as my head and it's my tails. So in this case, we can see the data here. The data of this and data of this. It is my 0.05 value. Instead of I called as 0.05 value. So it is my 5% of my data. 0.05. It is 5% of my p-value. Okay. So this is nothing but rejected null hypothesis. I call this as rejected null hypothesis. So it is my rejected null hypothesis. So it is my critical value. This is remaining nothing but my 0.05 value. So when it is called triggered, so 0. Nothing but we have alpha value. So rejected null when the p value is greater than alpha value. So it reject the null hypothesis. Okay, in simple terms. When the alpha value is greater than sorry, when the alpha value is less than p value is reject the null hypothesis. When the alpha value is greater than a p value, so it takes as it fails to reject the null value. Fail to reject the null value. So generally it fails when taking the null value. Generally it takes to fail. It take the fail has a null value. So it fails to reject reject null hypothesis. Right? When the p value is less than alpha, it rejects null hypothesis. Okay. When the p value is greater than p value is greater than alpha value, then it fails to reject the null hypothesis. Okay, indeed alpha is nothing but level of signification and it takes alpha equal to 1 minus confidence level. So we take as 1 minus confidence level, we can take as like that. So in the p value, it considers a little assumption 0.05 as 5% data. So in that I constantly take this data into I cut off this null value as a rejected null value. So this like we can call the probability value of the p value. In the regression table, we can find like this the data. Okay, I hope you understand, guys.